Yesterday we were talking about ionic bonds. Ionic bonds are when a metal cation and a non-metal anion come together to form a compound. Our metal cation loses electrons, creating a positive charge, and our non-metal anion gains electrons, creating a negative charge. The opposite charges attract, and we have an ionic bond forming an ionic compound. We had one slide of notes to get through yesterday, and that slide of notes looks at the properties of ionic bonds. There are 3 properties I want you to know. I want you to know that they have high melting points, that they're crystal solids at room temperature, and that they conduct electricity in solution. And I want you to know the why of each of those properties. The first one, high melting points. That means that we have very strong bonds. These strong bonds are a result of the transfer of electrons. One electron loses these precious electrons, and one gains those electrons. Because one loses, that element is very strongly bonded to its partner that has gained those electrons. That bond strength is very strong, so it takes a lot of energy, a lot of heat to break those bonds, and thus ionic bonds have high melting points. The fact that they're crystal solids at room temperature, solids are explained through the fact that they have high melting points. But the idea that they're crystal solids have to do with the fixed ratios. Remember that ionic bond compounds are going to form bonds with fixed ratios, meaning when sodium bonds with chlorine, it's always a 1-to-1 ratio. When lithium bonds with oxygen, it's a 2-to-1 ratio. This fixed ratio gives us a repeating pattern to those positive and negative charges. And thus we see nice crystalline structures come out. And then the third property that I want you to be familiar with is the fact that ionic compounds will conduct electricity in solution or in their liquid form. In solution means that we have a solid that's dissolved into water, and in its liquid form would mean that we took that solid ionic compound and melted it. As long as it's in solution or in its liquid form, it can conduct electricity because we have a separation of charges. That separation of charges works just like stones across a river. The more stones you have across the river, the faster you can cross that river. The more ions in solution, a positive ion, a negative ion, a positive ion, a negative ion, the faster that electricity can move across that liquid form. Those are the 3 properties of ionic bonds that I want you to be familiar with as we look at learning target 4, that says that I can recognize the properties associated with both ionic and covalent bonding. We'll talk covalent bonding tomorrow on Wednesday when questions 19 through 31 on your study guide are due.